Is anyone hungry by any chance? Would anyone like to have a burger, a nice juicy one like this one? Raise your hand. Be honest. Folks, you're in the right place. Portland has so many great options. And burgers is a tough business, but let's assume that we're up for a challenge and we want to create the perfect burger and scale it for a restaurant. How would we do this? We'll start with a recipe, we hire a team, we set a location, and set it up for success. Nothing is perfect on the first try, right? So, and being monitoring professionals, we want to see where we are. What works well, what doesn't. So we monitor whatever we can. We read user reviews. We invite food critics, get their opinions. We set metrics for whatever we can objectively measure. How quickly can we cook the burger? How quickly can we serve it? What's the consistency? What's the presentation? All of those things are very important because they give us an idea of where we are on a path to perfection. They tell us what goes well and what needs to be improved. But they don't answer the question of how. How do we improve? How do we change the recipe? How do we choose better ingredients? How do we choose better allocation? One way to address this question is to do A/B test. An effective approach is to change one ingredient, make a burger, give it to customers, collect feedback, and compare it to the previous version and see whether it's better or not. And then we scale it. We try different things and run it again. But as simple as a burger might look, there are so many components to change. So we'll need to run many, many experiments, and it takes time. There are also some things that are hard to A/B test, things like location or a chef or kitchen equipment. We can rely on industry benchmarks, on industry reviews, or we can set up a test kitchen, having a controlled environment where we can try and compare different things, iterate quicker. But there is also a problem, because whatever the food critic or a chef thinks might not be what your customers think. So you lose touch with your customers. Ultimately, our ability to reach the perfection and the amount of time it would take us on that path would depend on our ability to run those experiments and analyze the results to get a direction how to improve. And we want to do it at the fastest possible pace, as closer to clients as possible, and at the lowest possible cost. My name is Sergey Federov, and I'm going to talk today about the tools and techniques to address this experimentation problem. I came from Netflix, and in case I got you confused, I'm not actually cooking burgers at Netflix, even though it would be fun, I think. I work on a team that improves client network communications for Netflix traffic. And with my talk, I'm going to cover on how to measure and improve network aspects of your service. This is not a Netflix-specific talk. What I'm going to talk about can easily be applied in your product domain. My goal is to arm you with tools and techniques to make your products better, to iterate faster. And in my case, I'm going to focus on client communications. I'm going to show how to use the metrics that you already collect from your clients and build an experimentation platform deployed on your clients to identify areas for improvement and how to analyze those metrics to guide you on your path to perfection, to make your products faster, and do that at almost no additional cost. So let's get to this. As you may know, at Netflix, we take metrics very seriously. So we collect many aspects of the client experience. We collect metrics, all performance aspects of our application. And we correlate those metrics with the user experience and user impact. There are many great talks, and I'm not going to cover this. This is generally the area called the real user monitoring. This is a very powerful technique because it allows you to get data from your clients. And it gives you a meaningful data on what works well and what needs to be improved. But similar with reading reviews about your burger, it doesn't necessarily tell you how can you improve it. And in my case, I'm going to focus on my area of expertise, network communications. This is also one area that's pretty hard to test because network requests go over the internet. This is an infrastructure that you don't control. Nobody controls it. And many tests are hard to set up in a traditional A/B test. or it has a very high transition cost. Like, how do you test whether you need to open a new data center, or choose another data provider, or change the configuration of your protocol? The risk or transition costs are high to move your production infrastructure before you can start testing. And for many people, network is like a magical black box. I want you to think of it as a set of ingredients, set of components that you can measure, improve, and iterate on. When a client makes a request, there are a few services, a few components that contribute to overall performance. When you make a HTTP request, first, the DNS is used to resolve your host name to the IP address. And you can measure and control it. You can choose the DNS provider that you use. You can change your DNS configuration. In many cases, TCP protocol is used to transfer the data. And you can tune the TCP settings on your servers to change the congestion control mechanism, tweak the packet sizes. If you encrypt your traffic, you can choose the cipher suits. It would impact your server performance. You can control how much data you send, how you compress it, what application protocol you use, and what are the settings. Do you use HTTP 1.1, HTTP 2, QUIC, or something else? All of those aspects would contribute to overall network performance. And this is not all of it, because you can send your request to different locations, different data centers, cloud providers. You can use CDN. And you have to understand the impact, because depending on where your clients are and where your servers are, performance would differ. And even on the path from the same client to the same server, there are multiple options. Internet is a network. There are multiple ways to reach to the destination from the same origin. And you can route your traffic differently. You can connect your servers to the internet in various ways that might impact the congestion you experience on the internet. So all of those things can be measured, but my talk focuses on how you improve it based on your measurement. I'm going to talk about the experimentation system that we've built. I'm going to guide through some of the learnings that we've acquired along the way. I'm going to talk about experiment design and data analysis. We went into this area a few years ago when we started to think of kind of scientifically, quantitatively about understanding our traffic patterns. And we looked at available solutions. As I mentioned, network requests are hard to A/B test, but you can use what's called the synthetic monitoring infrastructure, which is like a test kitchen. You have the servers that are deployed in a controlled environment, usually around the world, and you can configure it as you wish. You can run different experiments, try different things pretty quickly with a low risk. But similar to the food critic's opinion, it might not fully represent your clients. And with the breadth and the scale we have, you're never confident that if the tests succeed in your test infrastructure, is it going to work on a weird TV or in a weird location in a remote part of the world? So we were not satisfied with the available solutions. We wanted to get data from clients. And there were no options either. So we decided to build our own. And it turned out to be a relatively simple thing. What we have is that we deploy a small agent alongside of our applications that we call the probe. And we configure it to run a test on a specified configuration, run some measurements. And we called this a test recipe. This agent follows the test recipe, gets the measurement, and then reports it to our analytics system. This is very powerful because it combines the power of real user monitoring. You get data from your clients with a synthetic monitoring solution when you have control over what you test. And I'm going to walk over some specifics of the test design using one of the first examples that we've used. To solve a problem for your clients, what would be the best server location or the best distribution of traffic between server location in your case? What we want to measure is the amount of time it takes to download the typical payload of your request from several server options all the way to the client. We want to measure the network part. So what we do, we deploy a simple endpoint at the edge of our data center that generates random data with a payload size typical to the payload size of your communications. And what the clients do, they're given a set of URLs pointing to those endpoints, and then perform an HTTP download. And they measure it for analysis, and submit the results for analysis. There are a few caveats, because the first question is, how do you run the test? Do you run everything in parallel or sequentially. With the systems like this, you run an uncontrolled environment because you have an application alongside of your test. And in that case, if you schedule things sequentially, there is a bias. It's like giving a sample of your burger before and after dinner. You'll have different opinions. Same way, if you run things sequentially, it might be different level of competition for device resources or network resources. So you want to run things in parallel. There are some caveats as well, because on certain devices, you're subject to the connection pool. And some devices restrict number of parallel connections that you actually send out. So even though you may think that requests run in parallel, they would actually be sequenced in a certain manner. So the solution for this is to randomize the order how you start. So at least in aggregate, you remove that ordering bias. And very important thing is to measure and change one thing at a time. In this case, in this situation, we want to measure the server location. We want to make sure that whatever configuration we have, like DNS configuration used to resolve host names, TCP configuration, server setting is the same across all options. So to recap, our test involves downloading and measuring the amount of time it takes to get typical payload of data from our clients in parallel and get results. And what we look at is the total time it takes. We want to see what would be the fastest option. It's always an exciting time when we deploy things in production. But one important thing is not to get carried away by the early results, especially if something looks too good to be true. And specifically in this case, if you see that one thing is significantly outperforming others, you really want to look at other metrics. If performance is better, are you sure that the failure rate is the same? Are you sure that the ratio of traffic that you get on each target is about the same? Try to avoid this shameful facepalm moment, so make it personal, not make it public thing. And for the experiments like this, aligning the error rates might be really tricky. Because if we think how we run it, we may depend on one of the tested targets to get the test configuration or to report the results. And we're subject to what's called the survivor bias. It means that if one of the tested targets that we use to get the test configuration is down, it's unlikely that we'll get a failure for this target. While if others fail, you'll probably get a result. This is a big problem. Like we've spent many weeks trying to find ways to resolve it. There are some solutions. There is no perfect solution for all the cases, but there are a few things you can try. If you can deploy your analytics infrastructure or routing infrastructure with several options, you should randomize how you get the configuration and where you report the results to spread the survivor bias across all tested targets. Or another option is to cache the test configuration or the results locally on the client and wait for a time when you can submit the results. So let's assume that we did all the right things and we still see the improvement. This is the time for celebration. This is the time to think about production. Well, not always, because performance analysis is a tricky thing. And you should really think a little bit about data analytics, because there are multiple ways how you slice and dice the problem. And I personally had lots of really fun time with our data analytics team, kind of educating myself. Because it doesn't make sense to look at a single number for performance, especially if you look at the breadth of your customers. You want to look at things like latency distributions to see how many requests are ending in a specific latency bucket. And here, if we compare two experiences, the current one and the experiment, we want to see how does the shape changes. Generally, if we see that the shape changes to the left, then we can see that overall we're improving the experience for our customers. This is also the typical way one can analyze the performance-related A/B test results. And we can look at this case in our system as well. It gives you the aggregate improvement, but it doesn't explain you where the improvement came from. What's the shape of the change? Have you improved all of the clients by the same amount? Have you traded off good experiences for bad experiences? And with traditional A/B test systems, it's hard to answer those questions. But in this case, we run tests in parallel, so we can get this information. What we can look at, instead of looking at two latency distributions, we look at the client result. We get the delta in the measured experience on the client basis, and then we plot the latency distribution of the delta. It gives us the information of what's the shape of our change. how many clients change by a large amount, positively or negatively. This is more data, and this is quite powerful. But this still doesn't answer some of the questions, like, if we care about the worst performing clients, like the tail distribution of latency right now, are we improving that experience? We're still not able to answer this question here. But we still can if we slice the data slightly differently. We can look at the current experience, at the latency distribution of current customers. And we can identify clients for specific categories of experience, like the slowest experiences and the fastest experiences. Then we look at the values of the experiment for those type of clients. We compute the same delta, and we aggregate the results per bucket. And then we plot those values on the same latency distribution scale, which gives us an idea what's the change in experience for the clients that are doing really well today and for the ones that are doing badly. For the example on the slide, we can tell that for the worst performing clients, we're improving the latency experience by a significant amount. We are also making things worse for someone who is doing pretty well today. All of those things give us lots of power. But there are different ways to look at the data. We also get data at the granularity of your client, of your device. It's really easy to get carried away. I personally spent hours digging through the rabbit hole. Because once you get the great power, you get the great desire to execute it. And especially in this case, you can spend a lot of time analyzing anomalies or fixing issues that don't impact your client. And the question is, like, what's the important improvement? To answer it, you need to go back to where you started. You need to look at the current metrics that you collect with the real user monitoring. You need to understand the areas of improvement, things that might make sense to change. For example, if you know that only the client requests above half a second contribute negatively to the user experience, everything else was blocked by something else, this is an area that you need to improve. This is an area where you need to set up your experiment and have this mindset during the data analysis. And once you get the learning, you deploy it, verify it with your current metrics, and rinse the repeat. And you do that in this sequence. You don't start with production and then figure out what you've done. You do this in a controlled environment. In this case, I've showed an example understanding the server locations. There are more things to test in pretty much the same manner, same configuration. You can test different DNS providers, compare DNS configurations, and understand the latency impact. You can try to tweak your TCP settings, your application protocols, and understand how it would change. And in this case, we are not doing any production change, so it's safe in terms of the client experience. This gave us a lot of power, but once we started to talk about it internally, we realized that there are more applications for this system. One of them is testing for availability of your system, which is especially important if you deal with internet, because the internet can break in so many things. So a quick show of hands, who has ever woken up at 2 a.m. at night only to know that the internet is broken and there is nothing you can do? Well, I definitely share your pain, because there are some cases when there is an outage in ISP. Things are broken, all you can do is wait. You can try to move traffic, but there is no impact. But not all failures are the same. It's possible that the failures only occur on the path to one of your servers, or your servers have an outage. And this is an actionable item. This is where you have to start fixing it. You have to move the traffic. And you need to know where to apply changes. So we can use a very similar experiment setup to answer this. Instead of looking at the performance amount of time it takes to download, we treat our endpoints as a health check. We look at the ability to get the response from various alternatives to the client. And at this point, we can separate different cases. A case where only one location is down versus the case where everything is down. And there are different action items for you in that case, especially if you deployed it not only on your infrastructure, but in a few locations on the vendor or alternative infrastructure, just to get a wider view of your network. So in our case, it helped us improve and clean up our logs quite a bit and added a few hours to our sleep. But now I'm going to tell the crazy thing. I'm going to tell that we can use this system to predict the future. to estimate the potential changes in our infrastructure without making the change. It's a relatively tricky approach, and I only have a few minutes, so probably it deserves a talk in the future. What it involves is that if you have your current metrics and you understand the relationships between your network and your experience, or your network calls and the cost that you're paying on different infrastructure, you have the network traffic model. And if you make your probing infrastructure the volume of tests, representative of the volume of your traffic, you can reason about the traffic impact and the performance impact of your changes of your tests on your traffic just by making a test. The analogy is what's called the painted door test that's used in the product. In the burger world, like if we know that the amount of time people knock on a door has connection to our revenue, we can just put the billboard in the remote part of the world and measure amount of people who stop by and guess the interest, guess the impact, without actually investing all of the time forward. So that's what we do right now. We run different tests. We estimate the network connectivity, reliability, or the shape of the traffic to the potential infrastructure that we could deploy. And we project the differences on our traffic model collected from today's client. And we understand the performance, the availability, the cost impact of making those decisions without actually shifting any production traffic. This is a very powerful tool for modeling. This really helps you to make guided, educated decisions. A few more words about how we use this infrastructure at Netflix. Currently, we deploy this agent alongside of every type of device. We don't run it right away. We wait a little bit, not to interfere with the client experience, and that's one thing that everyone should test first if they go with this approach. You want to make sure that your tests do not impact the user experience. So we sort of wait for the period of idleness and the client interactions. And then we have a dynamic test endpoint that tells us what tests it needs to run. It allows us to configure what tests we run at any moment and change it dynamically. Then the client performs the tests, get the results. And those results go into our decision-making system. We have a number of real-time stream processing jobs that power our decisions to choose the most optimal network path for our traffic. Because we have several regions in the cloud. We have our CDN. There are many options we can take. And we can know which one would be faster at any point. We use it for monitoring, to clean up our alerts, to build availability model of different pieces of our infrastructure. We use it for prototyping and performance analysis. We can predict, what if we change the cipher suite? Would we break any clients? Would there be any negative impact or positive impact? Again, without risking breaking any traffic. And we use it for modeling. As Netflix scales, traffic pattern might shift. Or we may have some different options as we evolve our own infrastructure. We want to understand the impact of it. And in this case, we can do that without actually productizing it first. Some stats, we run about 6,000 probes per second from all of our clients. Currently, we test about 14 different test recipes. All of the data comes at the granularity of thousands types of devices and millions of our users worldwide. This is an extremely rich and detailed data set. As a fun exercise, we try to analyze how much would it cost us to use a vendor solution. And even at the lowest granularity, it would cost us millions, if not tens of millions of dollars per year. And in this case, we practically pay nothing to get this data. We think that this is very powerful for us. We think that you can leverage it as well. That's why we are committing to push it to the open source. We have an early version of the JavaScript probe executor. It's in a better version. There might be some rough edges. We have to adapt our implementation to make it open source. But please give it a try. We'll also continue with the tech blog series to talk a bit more details about type of experiments that we do using the system to help you repeat our success. This is definitely not all my work. Actually, majority of work is from the team, and there was a huge help from our data analytics team, from our operations teams, that helped to understand what we built, helped to educate us on how to make decisions, and iterate on various issues that we found. So I hope that with my presentation, I was able to demonstrate the complexity and the potential of understanding your client network traffic. Use the power of your devices to run experiments at an extremely large scale, to help you to perfect your services faster. What I've shown is not a replacement for the tools that you use today. Rather, it's a powerful way to augment the metrics that you get today with the power of experiments running on your clients to help you make the educated decisions, to help you make your products faster, more reliable, your operations more predictable and controlled. This is a Netflix story, but I'm sure that many of those things can easily be applied in your domain. And I'm really curious to hear your story. I won't have time for Q&A after the presentation, but I'm around, and I'm really happy to address your questions or hear your ideas. You can reach me either in person or online. And the last thing, I am going to have a burger for lunch. Right across the street at the Deschutes Brewery, I have a table reserved that can fit a few of you. If you're interested to chat more during the lunch, please let me know and join me. Thank you so much.